Have you ever spent hours debugging an analog circuit, only to find that your carefully chosen operational amplifier just is not performing as expected? Many times, the issue is not the op-amp itself, but how it is powered. A stable and clean power supply is absolutely fundamental to unlocking the full potential of any operational amplifier. For reliable operational amplifier performance, the primary power supply requirement is to deliver stable, low-noise direct current voltages that meet the op-amp's specified operating range. Most op-amps requiring a dual-rail supply, meaning both a positive and a negative voltage relative to ground, along with a connection to the circuit's ground reference. The why behind these requirements is rooted in the operational amplifier's internal structure and its sensitivity to power supply variations. Operational amplifiers typically feature a high power supply rejection ratio, or PSRR, but this is not infinite. Any ripple or noise on the supply rails can be coupled directly into the output signal, degrading its quality. Furthermore, dual-rail supplies enable the op-amp's output to swing symmetrically both positive and negative around zero, which is essential for amplifying alternating current signals without distortion. The negative supply also allows the input common mode voltage range to extend below ground for many configurations. To achieve this, designers must carefully select power supplies with low output ripple and excellent regulation. Beyond the primary supply, it is critical to implement robust decoupling capacitors right at the op-amp's power pins. These small capacitors, typically ranging from 0.1 microfarads to 10 microfarads, act as local charge reservoirs. They supply instantaneous current demands and shunt high-frequency noise and transients from the power rails to ground, preventing them from corrupting the delicate analog signals within the op-amp. An often overlooked insider detail is the importance of a properly designed ground plane and careful capacitor placement. Placing decoupling capacitors to or from the op-amp's power pins can render them ineffective, allowing parasitic inductance in the traces to negate their benefits. Moreover, using both a smaller ceramic capacitor and a larger electrolytic capacitor in parallel provides effective decoupling across a wider frequency spectrum, addressing both high-frequency noise and lower-frequency ripple. Ultimately, providing a clean, stable, and appropriately decoupled power supply is not just a recommendation. It is a prerequisite for achieving predictable, low-noise, and distortion-free operation from your operational amplifier designs. Neglecting these requirements can lead to unwanted oscillations, reduced accuracy, and compromised signal integrity, undermining even the most meticulously designed analog circuits.